there's part 2. Oh, let's see. Ba-da-doo-boo. I am constructing a triangular brace for 2 pre-cut pieces of wood measuring 4 feet and 7 feet. Right here and here. Cool. I have one angle measuring 82. I put the angle bracket between the 2 pieces of wood. Piece of wood, angle, okay. What length of wood do I need for this piece? Well, this is not a right triangle, but any triangle is actually 2 right triangles, in which case we could use sines and cosines. Now if we're aiming to get this oops, we want to get this length here. It might help to label these things, you know, the way it would normally, because triangle has 3 sides, 3 angles. Let's see if we call this alpha, beta, gamma. Then over here we would like to call this A. And then we go clockwise. B, wait, nope. A, B, C. There we go. C, opposite side gamma, A, alpha, B, beta. Okay. So we want to know what is B. Okay. Solving for B. Let's see. What all do we have? We have an A is 4. B is what we want to find out. Guido, C is 7. We don't know alpha. We do know beta. Alright, and then we don't know gamma. And actually it might help to do the knowns in one color. Yeah, and the unknowns in a different color. Yay! Let's get this out the way. It's cluttered my view. You know what I mean? There. So, what are we looking for again? Oh, side B. Well, let's see. It don't look like we could use the law of sines because we need 3 out of 4. Here we only have 2 out of 4. Here we only have 2 out of 4, so law of sines won't work. We need the law of cosines. And it looks like we have it here. I don't know why there's a y there. What does that mean, dude? No. There's your Pythagorean theorem for a right triangle. If it's not a right triangle, then you have to correct it with the rest of this. Now, those go there, and this should be the angle opposite this side. Thank you, darling. So this right here should be a gamma, not a letter Y. And even if you are going to write the letter Y, don't write it like that. Write it like this. Because again, that can look like a yex. Don't want any yexes. So copy the formula down right if you're at least going to do that. See, that's the problem with memorization and stuff. We are humans. We're not good at that, transcribing things. Computers are good at that. They're dead. Right? So personally, I would have had to rederive this because I wouldn't have been able to remember it unless I'd been using it recently. Anytime I use something over and over, I remember it for free. If I have to memorize it, it's pointless because I only have to memorize things if I'm not going to use them. In which case, what's the point? Okay, so before you plug numbers in, let's see, for us, we want B though. So we could have labeled things differently, or we could use a different version. For us, we would use B squared, A squared plus C squared, minus 2, AC, cosine of the angle, opposite side. That's the version we would use. Yes, darling, you may. Enjoy. Yeah. So I just permutated, right? These two go here, just like those two went here. The angle opposite side, angle opposite. So that's what we want. So that means that B is going to be the square root of all this stuff. Again, square root is just a different way of writing 1/2 power. Please don't forget that. The only reason we have this radical symbol is because of the printing typesetting issues. Now, that's the answer. I mean, for me anyways, because look, we already have A, beta, and C written right there. So, yeah, we're saying A, C, and beta here, but we've already written them down. Why bother doing all the rest of this stuff? But of course, math teachers want you to do that. They want you to go, A is 4, C is 7, A is 4, C is 7. What's the point of that? We're just copying something down from from one point of the paper to the other point in the paper. I mean, what if I'd have just done this instead? Watch this. Do. Boop. Cool, right? Or what if there was a button I could click that just took all the letters and anywhere they were referenced on the paper, just switched out the visible display. See, there's no math going on there. It's just a manual task. Like digging a hole, but you're using your fingers and your hand. Okay. So, I mean, again, we were done right here.
I got the other egg collection.
Thank you, darling. So, yeah, you could say, okay, I'm done here. They want you to simplify it, whatever. Let's do some arithmetic in pre-cal. 4 times 4 is called 16. I like to call it 1/6. Y'all call it 16 because there's a hidden operation. When you have two symbols that each represent known quantities, the hidden operation is a plus sign in base 10. That's what y'all always forget. So 7 times 7, we call it 49. What is this? Those are both, well, 7's prime. Here we got, I'm going to write it like this. 2 cubed times 7. Why am I doing that? Look, when you do these, put a little lip, beep, so you know where it ends. Now what? You kind of have to combine those. 16 and 49, 40, 50, 65. So I wrote it like that because I wanted to see what this would add up to. 65 does not have any 2's or 7's in it. Because of that, I'll go ahead and turn this into 8 times 7 is 56. Because if there were, right, if this once added had the same factors of that and they had a duplicate, then I could have pulled something out of this square root. But that's as simplified as we're going to get. Boop. That's the answer. Don't mess with it. Yeah, go for it, darling. Eat the egg yolk. Nowhere here does it say to approximate anywhere, so don't. Oh. They did this though. This sucks. Now I gotta find a stupid calculator.
Can I have another?
Yeah, darling, go right ahead. Let's see, calculator.
Did you boil all the eggs?
A lot of them.
Well, did you boil all of them?
No, a dozen of them. Alright, what do we have here? 56 plus 65.
Oh, you did because it's wet.
Yeah, they're all boiled, baby. That was it, 85? Let's see. 82. Alright. Oh, dang it. I don't know how to... 82. I don't know how to do it. Maybe the... No, back end of the pencil doesn't do eraser. Oh, there it is. There. There. Now what? Do it. What is this equal to? Come on. How do I circle it? Command Z doesn't work, huh? Well, math knows. Square root is, dang it. Square root of 56 plus 65 cosine of 82 degrees. Do. Well, come on, dude. Oh, I did that. What about this? Alright. Haha.
Dad, do you want to see something? 1, 2.
Dang
That's what
it.
I'm going to do.
Let's hold on.
Dad, you've been wondering.
Can you see me try to make my video here? You cool with that? Oh, look at that egg. That's cool.
And I'll tell you how to take it off. Look. 1, 2, 3.
Ah, you pull its little hat off.
It's the egg time.
There we go. Ta-da! 8.065. Oh. See, Apple here is lying. That's approximately. So, we didn't get any of those. Huh. So, did I type it down wrong? Oh, it's 65 plus 56. Okay, dang it. Now, fine. Let's try that again then. Do. Or a bigger eraser. Yeah. Okay. Boop. Alright. Cosine of 82 degrees equals 56. 65 plus
Here.
the square rooting.
Dad,
Yes, ma'am.
I'm going to put my yolk.
Okay, thank you. Oh, what the hell? Come on now. I hate this calculator. Cosine of 82 degrees equals, multiply that times 56.
I'm going to have.
Add to that 65. Square root. What? Right. 65 plus 56 times cosine of 82 degrees to the 1/2 power. Haha, 8.53. What's not any of those? Okay. Fine. Let's try something else. Boop. Oh wait, we have Desmos right there. Bam, 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 bam. Alright, squirt. 65 plus 56 times cosine of 82. What? We have to make sure this dude is in degrees mode, because there's no degree symbol. 8.53. Alright, well, let's see. What did I do wrong then? So that's not any of them. C is 7, A is for ABC. So my formula, AC to AC cosine beta. A is 4, C is 7, or 7, beta, okay. Oh, wait, I added those. Aha, big O minus sign. Y'all been laughing at me this whole time. Huh. See, we're humans. Doesn't matter how good you are at the math. That's just a bean counting right there. Paying attention to little stuff. That's not math. That's anti-math. There you go. The whole point of the math is to minimize these things. Yeah, go ahead. Eat all the eggs you want, baby.
Yeah. You're the best dad ever.
Ah, thank you.
You're welcome. Thank you. Did you know I love eggs?
You do?
Yeah. I'll get that off of your computer.
Oh, okay. Oops.
Crack, crack, crack.
Is that it? I better look. 65 minus 56. There, 7.563. Boom. There we go. Moving on now. Which of the following points is equivalent to the rectangular point? Both negative, so I go backwards and then down.
You know how to open an egg? Look.
Let me see. Oh, yeah, that's how you do
I was
it.
drying it off, and then when I looked, it was like this.
Oh,
so
yeah?
I guess I can just pop my yolk out. I almost dropped the yolk.
Oops. Theta. Theta. R. They have negative R's. You can have that where you point in the opposite direction. Since all of their angles here are small, this is not one of the optional angles that they have, which is lame. So I knew they'd do something silly like that. You would never do this in the real life. Okay, so in which case they want you to point in this direction but have a negative radius. So I'm going to do absolute value of R, which is silly. So what's our angle here? Well, you could draw a triangle if you want. What's this triangle? This is a distance of 3. This one's a 3 root 3. It's just this triangle here. I'm just drawing it bigger. You do tangent because we have opposite and hypotenuse. So you could be like, I know that tangent of theta is opposite, not hypotenuse, opposite over adjacent. Right? And so if that's tangent, then theta is arctan, also known as tangent inverse. Tangent inverse always gives you an angle over here, so that'll work. We wouldn't want the negative one. That would be down here. We want the positive one up here. So that makes sense. Now I wrote that all silly. My brain's tired. Let's try this again.
There was only 3
Take
more
tangent
left.
inverse of both sides.
Wait, this one's wet, so you definitely boiled it.
There. So that's
Oh, you didn't.
theta. If you want, you could you can rationalize the denominator. Multiply top and bottom by root 3, if you like. Now what's r? Well, square root x squared plus y squared, or adjacent squared plus opposite squared, 3 squared, 3 root 3 squared, root. I'm going to factor the 3 squared out. What's this? So 1, and then root 3 times root 3 is 3. Right? The squareds. Now I could pull that outside the square root, because it's 3 squared square rooted, and 1 plus 3 is 4. 6. This is the absolute value here. And we know we want the negative radius. So we have that. Oop. I'll do this. Oop. There. Negative root 6. Oh yeah, we can simplify this. So check this out. Multiply the top and the bottom by half. No, actually, let's not rationalize that. That's why I never do it.
And maybe have 5 eggs. Ah! Yeah, I had 5 eggs.
Now multiply the top and the bottom by half. That looks familiar. Opposite is a half, adjacent. So it's a pi over 6, right? Yeah. There, that's better. Oop. There. There's our angle. I don't like that there, it looks confusing. Hey, so there you go. Roadrunner, initial population, okay, P naught, 6, starting point, okay, exponential, 4 years, boop, increase to 75, okay, boop, bow, 75, creating second point at 4, 75. Sooner the roadrunner population goes by the same percentage. All right, that means exponential growth. What's the exponential function? All right, so we know it's an exponential function. And then we have 2 points. Each point is an equation. So this guy here says f of 0 is 26. And if this is the form of our function, it would look like that. And they tell us f of 4 is 75. And f of 4 would look like this. And this one, since that's just 1, we can see right away a equals 26. Oops. All right. And this one, combined with this, boop, b to the 4th would be 75 over 26. So we want a 4th root. Fourth root, or 1/4 power. This right here is 25 times 3, 5 times 5 times 3. So we don't have any, that's not reducible. So our function, now we know a and b, would be 26 times b boop b 2 dx. There you go. Find the exponential function. That's it. All right. Well, this is your growth factor. How much it deviates from 1 is its growth rate. If you wanted to, you could rewrite this like this.
1, 2, 3, 4, 5, 6 eggs.
You could do that. Or you could do some other fancy maneuvering to change your base to E, if you like.
If it... Well... this one's safe.
So, I don't know where you got this decimal, dude. You know, when you just write a decimal down, where the hell did that come from? You typed something in the calculator. What did you type? I do not care about your end result, especially if you wrote it down where I don't know where it even came from. All right, 75 over 26 to the 1/4 power. Now I got to do this stupid stuff here. 75 over 26 to the 1/4 power is 1.303. That's not what you got, dude. 75. Oops. Over 36. To the 1/4 power. See, you just write some random decimal. Like, what is this?
I found this on the web for
I didn't even ask you. Get out of here, Siri. Stop listening. Ooh, uh-oh, I'm sorry, darling.
It's okay.
How about, okay. Let's put these on a plate. You got egg yolks all over everything. Golly, Lily, there's how many of these did you eat? Oh boy, that's gonna be fun. Here, you take these over here. Oh my gosh. All right. Oops, sorry. Let me finish this video for the students, okay, baby girl?
I did eat 6.
Good.
Yeah, I did eat 6 eggs.
All right. 6 eggs. Based on what is the population 7 years? Well, we already have the function written down right here, right? So the answer is, as a mathematician, that's the answer. Boop. Because F is known, right? If you want to, you can just rewrite some stuff for no reason at all. There you go. If you want to simplify this, you could be like, 7/4. There you go. What was it? 26 times 75 over 26. There. What you should do when you're doing this stuff is do this instead. F of x equals. By the way, you have the whole formula. Now if they ask a question, you can just do this. Yeah, go ahead. 166.00.
Now you take off one. I said take off one.
What? You want me to peel the egg for you? Alright. There you go. Alright, there you go, darling. And, yep.
Tee hee hee, I steal your chain.
It's okay. You want to sit on my lap, make a video with me? Alright, this is log, but they really mean here log base 10 when they don't put the base. So, the domain, well,
then where's log base 1
whatever
or log
you
base
plug
2?
in the log has to be positive. Why? Because the stuff that comes out of the exponential, you can plug in anything you want, but what comes out is always positive. Look at the picture. Plug in anything from left to right all you want, but what comes out is always up here, not down there. So that's for b to the x, right? Right? You never get anything out of it that's negative. And the log takes the output of b to the x as its input. Alright? And it returns it back to where it came from.
Yeah, it
So
had 7
since
eggs.
only positives come out of b to the x, only positives can go into log. So that's the domain, as that was the range. So the stuff inside here has to be positive. That means x itself has to be bigger than 6, or like that. That one. And ln, this is not I, this is ln, okay? Don't be writing this garbage, okay? Or this garbage. It's nonsense. ln, it's abbreviation for log base e, natural log. E is the natural base. There's a million ways to do this. If you don't like the bar, don't use it. You know, being on the bottom is the same as a negative exponent. If it's on the bottom and negative, that's it back up top. So because you have negative exponents, you never have to look at that bar again. So you got two rules. Log of the product is sum of the logs. Like that. And then the second rule is if you have an exponent, you can put it out front. So do that on each of them. There you go. I don't know what the hell that is. Alright. Okay, well, how do we want to solve for x? Well, it's stuck up there in the exponent, so to get it out, we need to undo this exponential. The inverse of exponential is log. So we're going to do a log base 5 on both sides. So this is equivalent to this. I just did log base 5 because those will undo one another. And now let's add 4 to both sides. This hot pink is hurting my eyes. Boom, that's the answer. Here, well, we got two different logs. Good thing we know that the sum of the logs is log of the product. So since they're both log base 2, that's a number and that's a number, those are the names. We can multiply them. Wait, this is a 3. This one's a 5. I don't like that. And why is that? That's because log of a number times a number is always log of the number plus log of the other number. Okay? Log of the product is sum of the logs. Sum of the logs is log of the product. Here is a number, and here's a different number. Oh, here. Dang it. Alright. Sum of the logs. Oh, there's multiple. Just because the names are x plus 3 and x plus 5 might make it look complicated, but it's not. Combine them. So now to get rid of log, we can do this. Oops. Alright, to get rid of the log base 2, we're going to do 2 to the power of on both sides. So 2 cubed is 8. Because that's not 0, we have to multiply this out. So you get x times an x. 3 times a 5. 3x and 5x will add up to be 8x. So that is equivalent to this, equivalent to this, equivalent to this. And now it's just a quadratic. Y'all know how to solve those, but I'll go through the thingy here. Move everything to one side so that everything is nothing. Subtracting 8 from both sides. This is easily eyeball factorable. An x and an x, a 7 and a 1. Okay. So by the zero factor property, a number times a number is 0. One of these has to be 0, or both. So x could be minus 1 or minus 7. But what about this original equation? The x plus 3 has to be positive. Otherwise, that thing's not defined. And over here, the x plus 5 has to be positive. That means x has to be bigger than minus 3 or bigger than minus 5, which means this guy is the authority here. So that one won't work. So somewhere along the way, we introduced an extraneous solution, which means one of these is not true. And I think it's when we went from here to here. Because if we plug in minus 7, this one is undefined. If I plug in a minus 7 here, I get a minus 2, and then a negative times a negative is a positive. So that's the step where we had the extraneous solution added. So really, we do not have logical equivalence. This is a fancy way of saying x equals both minus 1 and minus 7. This is a fancy way of saying x equals minus 1. So yeah, if x equals minus 1, that does not mean it's also minus 7. But if x is minus 1 and minus 7, then sure. It does mean x is minus 1 because we just said so. So that's the key there. Alright, 16 and 17. Oh, I guess we're done then. Alright. Oh, there we go. Did I miss any of them? Alright, there you go, folks. Hopefully that helps y'all out.